Hello, sir. I have written the code for converting the slokam, the Telugu slokam, into Unicode, and this is the function. This is the file which does that. So I have downloaded the file and I have opened it in R mode, which is read mode. So I can't write anything to this file. I can only read the text present in the file. So I am this returns an object, and I'm using the attribute function read in order to get the text, to get all the text which is present in this file. So sloka.txt will be a variable of type string. It contains all the text present in this file. And then I'm closing this because I don't need to perform any other functions or any other operations on the file which I have opened. So I'm closing it. And here I'm using the sloka.text, which is a variable of type string. Since it's a variable of type string, there is this attribute function called split, uh, the which splits the string into words. So words is actually, so this is the file and it contains a slokam. So when I execute this line of code, I have printed words, and words is shown over here. So each word is actually a member of this array. Yes. So words is actually a list of string, and each string is actually a word in this file. So, and then I have opened a new file where I write the converted Unicode into. And now, since I Googled about Unicode, and I found that every character, it can be in any language, every character is assigned integer. The value of the integer is between 0 to around 1.1 million. And this integer is then converted into a hexadecimal value. And this hexadecimal value is appended with the sign U plus. I'll show you, I'll execute, I have executed this function, and I have got the Unicode. So this is how the Unicode looks like. This is the code point value of each character. For example, one character over here is converted into this Unicode code point. So this character over here has an integer value. This integer value is then converted to a hexadecimal value, which is over here. This is the hexadecimal value of that integer, of this particular integer. This is the hexadecimal value. And this hexadecimal value is appended with U plus in order to get the code point value. So this is the code point value of the character, and this is the Unicode conversion. So this code, once I get all the words, which is actually a list of strings, what I do is I run a for loop through all the words, and and as you can see in this slokam, there are these characters, this character, and there are some numbers. So I have not converted those numbers and this character into the Unicode. I have only converted the slokam into Unicode. So whenever there is this word, for example, in words, there is a number, or there is this character. So if I is such a character, or if it is a number, then I won't perform the conversion. If it is not if it's not of this character, and if it is not a number, then I perform the conversion. So what I do first is uh, I is a word, it's one word, and it is also it can also be treated as a array, a list of characters. So I take one character from the word. So from this word, I take one character, and this character I feed it to this function called ord. Ord will return me the integer equivalent of this character. Once I get the integer equivalent, what I do is I convert it to a hexadecimal value. The hexadecimal value will return me something like this, 0x38. But when we manually convert an integer into a hexadecimal value, we don't get this character x. So this character denotes that it is a hexadecimal value, but we don't get this character X when we manually convert it. So what I do is I replace this X with a null character. So I get only 03E8. I only get this character, and I append U plus to this number 03E8, and I write it to this file. So that is what you can see over here. This is just an example, but actually it look like this 03E8. I just took an example of 1000. So the first character over here is this character. So its integer value may not be 1000. I just took an example over here to show that we get X, and I replace that X with a null character and I write it. So similarly, I write all the other characters in the word. So J is one character in the word, so I write it for all the other characters in the word. Once I finish writing all the characters in the word, I have a space. So that is what is written over here. There is a space, which means it is going to the next word. And I do the same for all the words. So this is how I have converted it into Unicode. And I have also written a function which converts Unicode back into the character form. So for example, over here, so once we run this file, we get this unicode.txt. So I'm opening unicode.txt in the read mode, and I'm getting all the text present in that file. In the Unicode file, I'm getting all this text present over here. And I'm also opening one more file called char.txt, and I'm opening it in append, which means I can write to this file, and whatever I write to the file will be appended at the end. So I'm opening the char.txt file. As char file, it returns an object with some attribute functions. And then I'm performing a split operation on the uni text. That is, I can execute this and show. So when I print words, so this is the uni text contains all the text over here, and when I split it, it actually becomes words is actually a list of list of each Unicode of each word. So for example, unitext is actually this entire string. So when I split it, words is actually going to be a list of these elements. So one element in words is going to be this, another element in words is going to be this, and another element in words is going to be this. So it's going to be a list of such Unicode words. And then what I'm doing is, so here I have taken an example. This is one such word. This is the word, same word. I have the same word over here. I have taken this and I'm splitting it. With the sign wherever U plus is there. So when I split it with U plus, I actually get this. I actually get this array over here. So what it indicates is U plus 0C05 is actually one character, and again U plus 0C2F is actually another character. So I'm splitting them into characters. So this is actually one word, and I'm splitting them into characters. And once I split them into characters, I'm actually finding the equivalent integer value, and using that integer value, I'm finding the character, and I'm printing and I'm writing it to this file char.txt. So that is what I have done over here. So I in words, so I'm taking each Unicode word, I'm splitting it up. I'll get something like this. And what I'm doing is J in character. J is going to be, so the value of J is going to be the member of this list. So if it is not, if it is equal to a null character, I am not doing anything. If it is not equal to null character, then what I'm doing is I'm appending X to this position. Like I previously mentioned, X was used to denote that it is an hexadecimal value, but when we manually converted it, X doesn't appear over there. But in order to convert it to integer, I need to have that X. So I'm appending X over here, Once I'm appending that X over here, I'm getting the equivalent hexadecimal value. So that hexadecimal value is converted to integer, and the equivalent integer value is then converted to a character, and I'm writing it to the file, char file, the same, writing it to the char file, and then I'm closing it. So when I execute it, I get this char.txt file, and I get the slocum back again. So there's also this sign which denotes that one stanza has been completed. So yes, this is what I have done, sir. Thank you.